Hello cave dwellers, welcome back to the cave where we're trying to revive a sickly CD32 kindly donated by Jason. We've seen the symptoms, we've seen the forest of capacitors within. The question is, can we fix and enjoy the last model to come out of the Commodore factory? There's only one way to find out. Fire up the soldering iron and let's take our CD32 from trash to treasure. Where to start then on diagnosing our problem? At first glance all seems fine on our board, but when you look a little closer, some things do come to light. Take these two capacitors for example. There's a very slight bulge on the tops of them and, as we'll find out later, something rather odd happened to them at the Commodore factory. The problem we saw in part 1 was that the picture was rolling up the screen. We tested it using the composite and the RF video outputs with similar results. Well, this week an S-video cable arrived and I could test the final video output port. Here's our board on the workbench with that S-video cable routed into my video capture rig. To my surprise, we had a solid picture on the S-video output, as you can see. So what does this mean for our restoration? Do we put it all back together, ignore the composite problems and use the superior S-video output? Of course not, that's not how we do things here, and it would be pretty foolhardy to leave a failing part which could cause further damage if it were to remain in place, a leaking capacitor for example. This behaviour also gives us a very good clue as to the source of the problem. If we take a look at this system block diagram, we can see Alice and Lisa making up the video chips. They pass the video data into a digital to analog converter, ready for output to our television. At this point, the video heads off down the S-video cable if we're using one. If not, it's encoded for composite output and sent to our composite out port. Or if we're using the RF output, it passes the composite output through to the RF modulator and heads out the RF port. Either way, it's composite encoded first. We saw problems on both the RF and composite output. What they both have in common is that composite encoded signal, so this seems like the natural place to look. Our video signals from Alice and Lisa arrive at a Sony CXA1145M RGB encoder chip here, where it's sent to the S-video port or composite encoded for those other ports. So let's take a closer look there. Here is that chip. Our RGB, chrominance and luminance signals come in here. And our S-video signal heads out here, utilising those luma and chroma outputs. The common denominator for the troublesome composite and RF ports is the composite signal, which leaves the encoder here where it says CV out. Now there could be a fault with this encoder chip, but capacitors 237 and 236 are also in the firing line as the signal leaves the CV out on pin 20 of the encoder. Those capacitors are located here. As it's easier to change a capacitor than the encoder, we'll start our fault finding with them and work backwards. This RGB encoder is also present on the Amiga 600 and 1200, so you may experience similar faults on those machines. Okay, so let's start with C237. I'll be using a hot air gun to remove it, so I've covered surrounding components with thermal tape to offer some protection to them. I've then dabbed some flux paste onto those pads to help conduct the heat into them and get that old solder molten again. You could also use a flux pen to apply the flux, whatever works for you really. And then we get to work with the hot air gun, trying to heat the component legs evenly and not lingering for too long in one spot, causing damage. Whatever you do, don't force the capacitor off the board. When it's ready to come, it will slide off freely. I just give it a gentle nudge once in a while to see if it's ready, but apply minimum force. We then give the area a clean with some isopropyl alcohol and clean it up with some solder braid to get those pads ready for a new capacitor. And then with a dab of solder on one pad, we carefully position the new capacitor so that both legs are in contact with their pads, and secure it in place using the fresh solder on the top pad. The idea is to slide it into place flush with the board. You don't want it perched on top of two blobs of solder. See here, the bottom leg isn't quite lined up as I'd like it, so we reheat the solder on the top pad and slide it into a better position. There we go. Then we solder it into place and we're ready to test it. Let's connect up our composite cable then and the power, and we'll hit the power switch and see if we have any improvement. And would you believe it? Our composite signal is now rock solid. Capacitor C237 was indeed the cause of all of our problems. So with that fixed, do we stop there? Of course not, we've come this far, and I'm going to give the board a full recap and clean up under all of the capacitors in case of any leakage, ensuring our board is ready for many more years of playtime in the cave. So, let's recap. A heat gun really is essential for the removal of these surface-mounted capacitors. You'll see other methods including grabbing and twisting the caps with a pair of pliers or cutting them off the board, which I'd advise you do so at your own risk because you do risk damaging the pads on the board or ripping them out completely. My heat gun is part of a very cheap heat gun and soldering iron desoldering station. I'll include a link in the description. I think it's worth a small investment for any hobbyist like me. Realising just how many capacitors were coming off the board here, I decided to mark all of the old ones so I wouldn't get confused with what I've changed and what I haven't, so that's why I'm drawing black lines across them. See here, I haven't protected the components quite as well as I should have, and I've knocked diode 641 as I remove the cap. We'll have to fix that shortly. When working around extra sensitive components or plastics which you don't want to melt, you can use kitchen foil to add an extra heat barrier and stop them from getting damaged. Okay, so you get the picture. Many capacitors, over 30 in fact, to be changed, carefully and patiently one by one. There are also 3 through-hole capacitors which need to be replaced, and this is interesting. Take a look at the 2 black capacitors here. There's a slight bulge to them as we saw earlier, only tiny, but there's a more pressing matter than that. You see, Commodore in their haste printed these revision 3 boards with the positive and negative symbols incorrectly for both of these capacitors, and as a result they're both fitted the wrong way around. So we need to replace them, but also reverse them. I've popped them out here and you can see the positive symbol near the screw hole to mount the board. That metal square should be grounded. When we test for continuity, however, we find that both the positive labelled pads are in fact connected to the ground. And that's not correct here. So the caps are fitted the wrong way around from the factory, and these two commonly fail, often giving symptoms of bad audio output as they do so. With these fitted the correct way around, that concludes the replacement of all the capacitors on the board, and it's time for testing. A quick power-up test confirms there's no smoke or explosions, and it's working with the full complement of new capacitors. Wonderful stuff. Now we need to clean her up and put her back together. Much of the board had been cleaned as part of the recapping process, but that power switch needed some attention with some IPA, and I gave the whole board a good brush with an anti-static brush to clear away any more dust or debris. The display board houses the reset button, headphone socket, volume slider for the headphones, as well as the power and activity lights. I gave that a good dust down. We've established that the CD unit is working, and I really didn't want to unsettle it. It doesn't look dusty at all or in need of any maintenance, and if it ever comes to it, I do have a spare laser in stock now. So we'll just give the remainder of the top of the case a bit of a dust around, and then get to the business of cleaning the outside of it. The cosmetic condition of the unit is in very good condition for its age. There are a few dings and scratches, but nothing major, and of course being that grey colour, there's no retro brighting needed. Always a bonus when it comes to these restorations. I've used some alcohol to remove the more stubborn stains, and then just wiped it down with some multi-purpose household polish really. I did consider using some car products like Back to Black or some other plastic treatment to give it that showroom finish, but these things don't last. You're back to where you started eventually, and while it may look nice, it would give you an untrue reflection of the final finish of the refurb, so we don't want that. Everything goes back together as it came out, and of course remember to squeeze the shielding around those composite ports again. The fiddliest bit is reattaching the cable from the CD drive, but I managed to slot that in eventually, and with the addition of some new case screws which were missing when this unit arrived, our CD32 is complete again and ready for the final test.
long last, Trill is a free man.
I think it's safe to say our restoration has been a success. Any artifacting you see on the screen is as a result of my camera. The image is in fact perfect. So what remains for this series? Well, games. Lots and lots of games are coming in part 3, as well as expansions both old and new. In fact, we're going to try and turn this CD32 into a full-blown A1200 using some of those expansions. As always, I hope you've enjoyed today's episode. If you have memories of the CD32, good or bad, do share them in the comments section. I'd love to hear about them. Come back to the cave soon, and take care. Retro Man Cave is made possible thanks to the patrons scrolling up your screen now. If you'd like to support the channel and future episodes, then consider visiting my Patreon page via the link in the video description. Your support is greatly appreciated.